Hello everyone and welcome to the other series of our tutorials regarding the C++ and problem solving. Alright, so in this point we are going to discuss more in more details about the for loop. Previously, if you remember, we have discussed about the do while loop, if you remember, and we have taken some examples in this. Alright, so let's just see. In the for loop, it is actually a pretest loop. As you can remember, we have the while loop. It is a pretest loop, if you remember, meaning that it is testing or evaluating a certain condition and then executing a certain piece of code. So it is a pretest loop that evaluates, that executes zero or more times, and it's useful for counter control loop, meaning that the user is actually controlling the loop, or the loop is actually having a definite number of iterations to go through. Okay, so the format is actually like this. It's as simple as this. So we have the for keyword, as you can see here, open bracket and then close bracket. Within the bracket, we will be having three items here. Basically, we have three items. First, initialization, meaning that the starting point or the starting value of the counter, and then the test, whether the counter is actually greater than or less than a certain bound, and then we have updating the counter or update for the counter, the iteration. I mean, like the rate of increment or decrement, we have it here. And then here we have open and close brackets, and then within the brackets, curly brackets. Within these brackets, we have our statements. Whatever statements are they, could be like cout, as we mentioned, or like any kind of calculations or logic. Note that here, as has been drawn here, you can see that we have semicolon here. It's very necessary. So between initialization, test, and update, we have to have the semicolon. But unlike the do while loop, if you remember, we have to put here a semicolon. You remember that? So we don't need to have that kind of semicolon. So don't confuse actually on this. All right. So uh, the orders of like the execution, like how the compiler is actually looking at that for loop, it is actually starting as has been shown here. So step one, first it comes to the counter. So the counter should be assigned to a value, starting value, and then initialize with an expression. And then step two, come to evaluate the test expression here, whether it's true or false. So counter here is equal to 1. Is if, like, for example, is counter is 1 less than or equal 5, then yes, this is true. Then it goes to the step 3. It doesn't go here. This one is actually step 4. Although it's actually coming in the same line, but this is the logic. So we first perform initialization, evaluate, and then execute the body of the code. Finally, we increase or decrease the counter. In this case, we are increasing the counter. So here, remember this. So this is increasing the counter by 1, or the count. So this is the variable. So if you notice here, all these operations here are happening on the same are happening on the same variable here. So initialize the variable, compare the variable, and then we increment the variable. Well, this is actually a logical display, or a logical display of like what you can see as the flow chart of that. So we first initialize the code, as has been saying here. So I'm trying to match with that. So this is the first step, comes in here, initializing the code, and then comes to the test. That's the test here. Count less than or equal whatever value, and then if it is true, then it goes to the statements and then iterates back to the update. So it goes to the statements here and then iterates back to the updating the loop. If it is false, of course, it will end up the loop and neither iterates nor executing the code. All right, so it's very simple and straightforward. I want you to remember this this kind of flow chart, and then I'll be having actually another session introducing you about actually more into more about flow charts and how to connect the flow chart or translate these flow charts into code, or and the way opposite. I have also, if you remember, I have given you previously some exercises, so I want you to go through these exercises that have been uploaded on the EduWave. You can just take them as a starting point. I will be updating them, of course, to include the looping, because these exercises doesn't include actually the loop It only includes the, I mean, like the logical testing using the if condition. Well, just coming back, this is a very simple example. This is like one of the trivial examples that you can think of as for the for loop. Like you can see here, so we first initializing a variable with a certain value here. This is sum, and then we also define a variable here, so it doesn't has any value. So num is a variable that it doesn't has any value. So we started the for loop by typing for, and then open bracket, and then the number here we initialize it. I mean, like the variable that we have defined here. So now we initialize it here. So this is a variable initialization, and now here we compare that initialized value with another control value. So this control value, in fact, it can be either a constant, as you can see in this example, or it can be extracted from any other variable that has been defined previously, of course, before the before the loop. And then, so if it is yes, or if this condition is happen to be true, then we increment the sum plus equals sum plus equal num. It means that sum equal to sum plus num. So I think you're already familiar with this kind of style and formula. And then, so here the sum of numbers 1 to 10 is, so this is just a text message to display, is sum. So that will actually display this out of the loop. So it's because we don't have brackets here, particularly in this example. So the only statement that belongs to the loop, it's this statement. What about this statement, the C out? It doesn't belong to the loop because we don't have a bracket. So if we have a brackets including like starting from here until here, then we can say that yeah, everything is already inside the loop, and then only, I mean, like both statements will be iterated. So how many iterations do we have here? Let me ask you. We will be having from 1 to 10 because we have equalization, so 10 will be included as an iteration. So from 1 to 10 will be equal to not 10 number of iterations. So what are the statements that are going to be iterated here? It is actually this statement, sum plus equal to num. This is the only statement that will be iterated. What about this statement? This statement is already out of the loop, as I mentioned to you. Okay, so let me just have give you a shot and tell you how is this going to be compiled. I'm just pasting it here in Visual Studio, as simple as this. So I will just simply take the code without any modification, just to give you like the visualization of what is going on here, as you can see. So from 1 to 10, this is because of that typing here. So it's because this one is not actually a programming. Simply see that dash has gone to smaller. So if you have compiled it again, there you go. So this is what you will see. So a sum from number to 10 is 55. So the logic of this question, actually, it's just to sum 1 plus 2 plus 3 plus 4. I mean like each time we are plussing. So plussing 1, 2, we're starting actually like by plussing 0 to 1, and then 0 to 1 to 2, and then 0 to 1 to 2 to 3, plus that. So that will be actually, it's just actually a kind of like a dumb code to say. It doesn't has any logic, but you know, it doesn't has any, not to say a logic, it doesn't has any real reflection in the real life um, problems. But anyway, it's just performing a specific logic. So whether this logic is useful for us or not, or like it makes sense or not, but anyway, it is still just a kind of a logic that we need to implement. So anyway, so this is the code that produces that, as you can see here. All right, so as we can see, also I want you to notice this. We are only able to produce one line. Why? However, we have a loop here. It is because this number, like the printing statement, happened to be outside the loop. So let me just indent this here for you to remember. This statement is located outside the loop. Then what is the statement that is inside the loop? This is inside the loop. Okay, so that will be it is. So all right, so let me just take the shot now before we just proceed into the slides, since we have already started with the Visual Studio and the coding. Let me just take this And what if I want to make it a real loop? I mean, like I want the output to be producing something like that can be iterative. It seems like an iterative, meaning that like a number from 1 to 10, for example. I want to display numbers from 1 to 10 rather than having the sum of these. Or let me just like modify that code a little bit here. So I will just let me just comment that code for a while, and then I will just use the brackets here to show you the like how important is actually using the brackets in the code. So that's why my advice to you, whether or not you're using only one statement or more than one statement, we have to implement. Like it's much advisable that we need to implement that. These brackets, because they will help us to avoid any like any future errors. Okay, so if I see out sum is, I'm just like trying to play out with the code, and then I write sum. Let's see what's going on here in line. Okay, so close this and recompile again. You see here, this is my, like this is the more, it seems like this is more actually more clearer than the previous example. See, first sum is 1. Why? It's because like num started from 1, so 1, like sum will be equal to sum is 0 already, so 0, sum will be equal to 0 plus num is 1, so 0 plus 1 is 1. And then coming back again, so now sum has been storing a value of 1. In the second iteration, 1 will be equal, sum will equal to its value, which is 1 plus 2, the second iteration of number. So 1 plus 2 will equal to 3, and then 1 plus 2 1 3, and then in the third statement I will have sum as 3, so 3 plus 3, and then will be equal to 6, and 6 plus 4 in the other iteration, and so on and so forth until I can reach to 55. Okay, all right, so you can just actually play around with the code. We don't need actually sum. For example, I want to display numbers from 1 to 10, as simple as this. So you can just simply say, like remove this all and simply to have num. So if you want to display numbers from 1 to 10 are num. That's as simple as this. So here I'm actually displaying like this statement will be iterated like for 10 times, and each time it displays the counter. This is the counter. We call this as the counter. Okay, and this is the counter that has been evaluated to the controller, and then here we increase the counter. So here we are displaying the incremented counter here. So if we just if we have run that code, this is what you'll see. From 1 to 10 will be 1 2 3 4 5 up to 10. Okay, so that's very simple and straightforward. So I think even like this kind of loop is actually most widely used, and even actually very important. Even it happens to be like the most popular kind of loop. It's because actually it controls the output. Like it controls the bounds to be like within a starting point or within a minimum bound and then an upper bound. So that's why it is very actually useful and very commonly used in many applications. Okay. All right, so there are many notes that we can take care of here. Regardless this theory and this like conceptual explanations, let me just summarize them for you. Like for example here, the first note is test. If test is false, then of course there will be no loop. If this happened to be false, like imagine that number has come to be 11, for example. So is 11 less than or equal 10? No. So then this piece of code will never be executed. So this is what does it mean? So the update of expression is increment or decrement by any amount. So we can increment it. It's not actually restricted to be incremented. This is the increment. It is not restricted to be increment or decrement only by 1. We can increment it by 2, by 3. We can write here num equal to num. Like let me just modify this. This is what I mean actually. We can like type here, for example, for int x equal to 0 or 1, x is less than or equal 10. I can say actually here in this particular code, x equal to x plus 2. So it means that actually I'm like instead of adding 1, I'm adding 2 each iteration. So this, but actually this will not make a sense, by the way, because in this case we are not actually increasing by 1, we are increasing by 2. So I mean, like the total number of rounds in this case will be 5, because like we are actually skipping one each time. Not only 2, we can increase it by 3. We can like have actually another even value for, I mean, like for x, we can say that x multiplied by, could be like a multiplication by 2 or by 3. So what I want to say here is that x can have actually any kind of value. This is very flexible, but actually, of course, this is not common, and this is not commonly used. The most commonly used one is either minus minus, or even the most commonly used one, it is plus plus, because in most cases we want to increase the loop, not to decrease the loop, even though. All right. So anyway, this is still a note, so variables are used here in the initialization section should not be modified within the body of the loop. This is a very important thing. So whenever we initialize that num here, we cannot say here underneath that num plus plus, meaning that we do not want, I mean, like it's not possible to, I mean, like to increase that variable here. In the same time, we also cannot say that int num equal to 1 again here. So this is of course wrong. All right. So these kind of practices are kind of, I mean, like they are considered wrong. All right. So you see, like this is it. For example, here. So this piece of code, this is wrong. Why? It's because we are incrementing the code 2 times here. We are incrementing x, which is the counter, 2 times here. So and another point, actually, there is a variable. I mean, like there is a scope for the variable. So if the variable, I mean, like that count, the variable, I mean, like the variable that we want to increase and evaluate happen to be initialized here inside, and it can be actually, and even I'm telling you, this is the most common practice. It's even more commonly used uh, um, than defining the variable outside. So in most practices, we used to define it here inside the code. So since because we are defining that variable inside the code here inside the for loop. So this is the scope of the loop, we call it. So whatever between between the brackets here, it is called the scope of the loop. So here, cout count equal to count. So we cannot actually use now count outside. Why? It is because now this statement happened to be outside that loop, because this loop is only defined by only this statement. All right. So meaning that whenever we define that any variable within the loop scope here, this is the loop scope, we cannot use it outside its loop. Okay. All right. So let me use that um, laser point, clearer pointing. All right, modification, more loop modifications here. So it can define a variables in initialization code. So I mean, like their scope is for loop. We can initialize actually a variable like what you have seen here. So as I have been mentioning to you before, it's also possible, and I'm telling you, this is the most common practice, even much more popular than defining this variable outside. So it's much better to define a variable within the loop itself. Okay. So this will make this kind of variables kind of special, to be only used within the loop body. All right, so initialization and update code can contain more than one statement, as you can see here. So we can actually initialize and update even more than one statement. But notice that, so they have been, I mean, like whatever initializations here, they are not actually separated by semicolon, they are separated by comma. Remember this is very important note. There's a difference here, because here this is just one type. We call this just an initialization, a variable initialization, but here this is evaluation. So it seems that like this is a different item than this. So here there are two items under this, I mean, like under the initialization step. Okay, so we actually separate them by using the comma, as you can see here. Actually, there are many more modifications. However, these modifications, in my opinion, they are not really recommended. I don't really recommend you to go with these kind of modifications. So it's much better for us to use the classical way of implementation, or like classical way of defining I mean, like the loop, which is this one. This is actually the most classical and the most well-known style for loop, that we define the count, I mean, like the variable inside the loop, and then compare the variable or evaluate it, then execute, and then increase it. any other styles that we modify it other than that, it considered like um, not really recommended, and even it may not have any kind of a meaning that we can reach to. But when we talk about like C++ and for the sake of learning, I also, because you are learning that code, so it's much better for you also to know how can we manipulate and modify that. Okay, we can omit initialization as you can see here. So this part can be can be removed here, while we just last with only two parts. It's also possible to do that. How? By actually moving this part outside the for loop. I mean, like outside before the for loop. Okay, we cannot actually make it. I mean, like under the loop, because of course, as you remember, just refer back to the I mean, like to the rule that says the variable have to be initialized before it's used. So it has to be defined before it's used. Okay, we can omit the update also here. You see, so here the update can also be omitted and can be used within the body of the loop. Also, the test can also be omitted. So meaning that we can actually manipulate, I mean, like the different types, I mean, like the different parts of the for loop. So either we can put that here, underneath that here, or even we can remove it at all. Either also we can actually omit the body of the loop if, I mean, like this is the body of the loop. I mean, like sum plus equal none in this case. So we can omit it if we just have all the variables here. I mean, like all the elements that we want here are fulfilling that. But again, I'm saying these styles are not really recommended to. So for your level of learning, it's just for you to know that these are the modifications that can be done. But for your practice, of course, you will not be actually doing this in any of your tests. All right, so this is just like a completion of what we have discussed in the modifications. As you can see here, we can actually initialize more than one variable, and even we can increment both variables. So this is very flexible. This means that actually the for loop is even more popular, and this is why for loop is actually considered one of the most important looping and one of the most important, I mean, like one of the most common loops to say. It's because we can actually customize it as much as possible. Not only for two variables, we can add as much as possible of variables. But let me say again, this is actually not the command style of like the for loop. As I mentioned to you, the command style is just by using one variable initialized to a value, not two, and then comparing that value with I mean like an upper bound or controller, and then we increase the variable, of course, after we execute the body. Okay. User controlling the user also may have actually I mean like an instruction to control that loop by entering I mean like that upper bound. So this is the upper bound that we talk about here. So a user may also be able, as I told you, so this is a constant value. We can also extract this value from a variable. Let me just test this with you in order to see how it is. So imagine that I just want to use exactly uh, the same example. I just want to simplify this for you. Uh, we don't know we don't want to use sum here because it's not within the example. All right, even I do not want to use this because like my style of programming, I like actually to define the variable inside. This is actually my experience, and this is what I even recommend you to do that, unless of course some questions may ask you, or some cases, some problems may ask to define this variable outside and then we initialize it. Yeah, in this case, yes, of course you can like then do that style. Well, all right. So what I'm saying here, I do not want to use a fixed value. Imagine that I want the user to enter the value. So as you have learned before, how can we allow the user to enter the value? It is by defining actually a value that you just defining a variable. Just give it any name. Could be like in this case maximum, maximum iterations, maximum round, for example, rounds. And then this is just a definition I'm saying because we want the user to enter. So meaning that we use a cout to prompt the user enter the number of iterations. All right, so the user now he already knows what he is going to do. So cn max round. So it's already defined here. So now the user is able to enter that. So here I can use that variable in order to reflect or in order to get whatever the value that the user has entered. So what is the data type of this variable? It should be int. of course. And I want you actually to remember this. I want you to notice that. I want you to know that as long as you are using, I mean, like you are reading I mean, like the value from a variable here, so that variable has to have the same data type as the counter. This is very important, actually, meaning we cannot actually compare, because at the end you cannot compare an integer with a double, for example, or you cannot compare an integer with a string if this is happened to be a string or char. So this is a very important point. So we need to know, I mean, like we need to remember this. All right, so this is it. So we have now by doing this, so we have already allowed the user to control the loop. So that now the user he's already entering that, I mean, like any number that he wishes in order to control the loop. Let's say I'm entering 4. So here 4 times 1 2 3 4. So as simple as this, you see. So now the user has the command to control the loop. So it's very easy and very common. All right, so this loop again here, this is an example where the loop will never iterate. Who can tell me why here? You just take a look at this code. I even don't I even do not like to, I mean, like to answer it for you because it's already clear from the code. You just take a look at here at the values here. I think you already guessed what is the, I mean, like why is the reason that this loop, if you copy paste it in any compiler, it will never execute. Something to do with the values here. All right. Okay. So all right, so let's just take a look at the examples here, like one of the examples. I will just go through with you in one of the exercises here. For example, write a program to display the following output using for loop. I think you have already an idea now how to start writing the for loop. So let's just take this in our mind. So we want to follow this output. So having this output, we want to write a program to display this output, of course, using the for loop. All right, so let's just start a clean code here also. Okay, so this is the program output, number and square. So we have two variables here, number and then square, or we can even have the number itself, okay, without this square. So let me just write this int num. Okay, actually I do not want even to define it here, so I will just start right away writing the for loop int num. As I'm telling you the style, int num equal to 1, num less than or equal, num is less than or equal, how much, that should be 5, less than or equal 5, then num plus plus. So inside that loop, because I have an iterative number, so meaning that I will have a display, kind of display, but before the display, you see, because I have this display here, it happens only for one time, which is this line, the number and the square, and then I mean like the series of dashes here. So this means that before I go to the for loop, I have to write this, I mean like a display, a C out to display this kind of pattern here. So I will see out. It's just I mean like a text, number and square. So that will be number number. I will use a set width, if you remember that set width here will be 7, for example, or let's say 5, because I want to allow some space, as you can see here. So this is some space. I want to allow this space, and then I want to add the square. Okay, so I don't forget the end line. And then I will go for the other line, which is this line, the dashes, see out. So I think this way, see, the more you practice, the more you will know. So end line again, as you can see here. So let me just execute that. Even with that for loop, never mind, because the for loop has been written correctly, nothing wrong with it. So if I executed that, I will have this. So it seems that I'm having a lot of dashes here. So let me just increase this up to maybe 8 and see how it goes on. Okay, so it started to work. So then I will need to reduce a little bit of the dashes here. All right, so this seems kind of nice. Okay, so in the body of the loop, what I will have here is not just a C out because I'm displaying here. I will have the C out both for the number and the square. So the number is here, C out num, and then I will have here actually before the C, I mean like before the num, I will have sit with here. That could be, for example, 4, let's say, and then I will have, oh, forget that. That shouldn't be actually an error. Okay, because I want to allow some space here. That's why I'm putting this. I want to allow this space in here. So, and then I will just copy that same sentence because I want to use it sit with, but in this case I want to have it much bigger than this, and then num multiply of course by num because it's the square. Or if you remember, we do not want to use this, we want to use the pow to practice more mathematical functions here. Num dash 2 as comma 2, and then here in line. Okay, so let's just run this code and see how it is going to run. Wow, that's very great. So this is it. You see, so it's very clear and neat, and you can now display this. So imagine if I move that line here, what will happen? If I move that line here inside, let's say that I do not want to have this line here. See, it will iterate. It will iterate, you see? It will look kind of, weird, very weird. So that's why whenever you see that kind of this display, you need to understand that this one, since it has been displayed only for once, it has been printed out for once. So meaning that it of course has to be outside the loop. So this line and this line have to be outside the loop. Okay? So of course, this shouldn't be the practice. All right, so this is like the code once again. Okay. All right, so let's just move forward. Let me just stop here actually for you, since since we have already covered all the aspects in the for loop. I would like you to actually go through the exercises and the checkpoints within the chapter. I will meet you in the next tutorial to continue with you in the over the upcoming points. So with that, thank you for watching, and I will see you later on.